Hey everybody, this is Alex Merced, and welcome to another episode of Gnarly Dataways. And we got to get on to our featured presentation, which I am quite excited about. We're going to be talking about building a data science platform on Apache Iceberg and Nessie with our guest today, Jacopo Tagliabue, a founder of Bauplan Labs. And Jacopo, the stage is yours.
Again, thanks so much. Thanks so much for having me. Today we're going to talk about some of the things we're doing at Bauplan. Bauplan is a new, mighty, small startup that just got funded this year by myself, Ciro, and Mattia. We are previous entrepreneur. This is our second startup. The first one was a startup in natural language processing, before it was cool and all, before large language model and all of that. That got acquired by Coveo. We led AI and MLOps at Coveo for 3 years, and we saw the company going from growth stage to IPO, and then we left to build our second company, and we're backed by pretty cool folks. And what we set up to do was basically to build the type of tools and platform that we didn't have when building our own company in the first time. So few words about what we're trying to achieve that will hopefully serve as a good segue for the type of technology choices that we actually made along the way and that we are here to share with you. And of course, ask for your feedback, questions, and comments. The first thing that I want to say is you may or may not be familiar with what people building data pipelines do. Of course, you may be familiar with people querying, like for example, Dremio for BI use cases or for some data exploration. And of course, this is all part of what a good data person does. But there's a component of this which is more akin of kind of taking different Lego blocks and putting them together and stitching them together to go from, for example, something in a data lake that you can query to, I don't know, like a data science model or an aggregation or a report that somebody else in your company can consume. And these pipelines tend to be multi-language, as in sometimes you want to use, for example, SQL because of all its strength and optimization and its expressivity for aggregation. But sometimes you want to use Python because maybe you're doing, I don't know, data aggregation with another API, or maybe you're doing some sort of like weird transformation that requires a Python package that somebody developed for you. And so you want to kind of mix and match these two. And so that's one aspect of it. And the other aspect is that pipelines, like this one is like a very easy one, but pipelines may be comprised by hundreds of different steps. Some of them are steps that are like manipulating data, like normalized data here, which is like a fictitious script, but you can guess what it does. Sometimes maybe quality checks. There's an expectation file here that you find here that is sort of there to be a symbol for data quality check. So sometimes when you normalize your data before progressing on with data transformation, you want to check that everything actually checks out. So the day in the life of a person like me, for example, in my previous company, was mostly assembling these Lego bricks to go from something that stays in our S3, in our data lake, to actually artifacts and features and tables that other people in the company, or even myself in a downstream system, would like to use. Our, let's say, philosophy stems from this quote, which is very famous in computer science, but it's often neglected when it actually comes to building systems that people use. So programs must be written for people to read and not incidentally for machines to execute. When you look at data pipelines and data transformation tool nowadays, it seems that humanity have solved the problem, or is become reasonably good at solving the problem of running data pipelines when no humans look at them. For example, when you need to run at night, is a bad job. Doesn't really matter how fast it is, as long as it runs and is reliable. So when machine needs to do this, there's quite a bit of good tools, open source and closed source, that can help you do that. But what is very, very hard to do is that when you are actually spending time in front of the machine, when the feedback loop is what's the most important thing, that current tools we feel are lacking. And that's, the fundamental philosophical reason why we're building pipelines. Sorry, why we're building Bauplan. So what we say is like pipelines must be written for people to read and all incidentally for cloud to execute. So more practically, what is Bauplan? So we define Bauplan as a serverless computing platform for data transformation. Okay, so you start with your code, SQL and Python. We saw the pipeline, the DAG example before, and you ship it to Bauplan, and Bauplan is going to run it for you. We have 4 tenets, as in we focus on mixed language tabular transformation over data lakes, and we can go over each one of these keywords right now to understand exactly what is the scope of our platform and what we believe we can help people with. So multi-language is easy. We support both SQL and Python. We work with tables and not files, which, what this may seem like a trivial thing to say, it become very important in what follows today. Third, DAGs have many nodes that need to be reused, right? When you move away from like point-wise query of like, hey, I just want to run this query now, to I want this query to create an artifact that other people can build upon. That's where, the concept of table kind of stretches to the concept of series of table, which again is going to be very important in what follows today. And finally, we believe in the, let's say, composable data system view of Wes, of Jacques, and other people in the data space. And data lake and data lake houses are the right architecture to build upon. So you don't move your data, compute come to your data, and different computes will specialize for different use cases. We believe in a future where enterprises will have not just Bauplan, but will have 3, 4, 5 tools that will all speak to each other through open formats, like Iceberg, for example, that we're gonna discuss today, and they're all gonna be the best in doing some specific data work. So when you go down from the philosophical view to what type of actually product goal we set ourselves when building this new company, we have 2. One is we want to minimize infrastructure. And the reason why we want to minimize infrastructure is we believe the data practitioners should focus on what they know best, the structure of the data, the transformation, testing for quality, and not spending time to learn or manage Kubernetes cluster, Spark out of memory exceptions, Airflow, idiosyncratic deployment mode, and so on and so forth. What we really want is people to focus on their code, because the code defines data transformation, and leave everything else to the platform. The second goal is we want to reduce the feedback loop time. That is, we want to reduce the time that it takes for you to go from I'm doing something that I believe will improve this pipeline, or I'm building a new pipeline, and then I want this to become part of my production system, right? And the crucial point about data system as compared to normal software system is that data system should really only work with production data. But then if you work with production data, you may end up causing problems in the real infrastructure that other people are using. So we're kind of left in this conundrum, right? We want to develop over production data and be very fast and kind of shorten the feedback loop from experimentation to production. But on the other side, we're very skeptical, very aware, very cautious of touching production for real. So how do we solve this? So the question we're going to set ourselves to answer, and that we're going to go through today in a bit more depth, is how do we move with production data fast enough while not breaking things? Because moving fast with production data may be risky if you don't take the right precaution. And the other option, which is not using production data, but using fake synthetic data for developing data pipelines, may actually make your feedback loop much, much longer. Because it may happen a lot of the time that your data is not representative of what you will find in production. And so what you think works in dev will never actually work in prod. So the first thing that we need to do to achieve our goal is move from the concept of, lake to the concept of lakehouse. And of course, Alex, you, and of course, Dremio had a lot of incredible content put forward on this. So hopefully, our listeners are already somehow primed for this topic. So the first thing, which may be obvious, but is that people don't really think in files. Sure, when you want to do some, small data analysis or exploration, it may be that, you receive a CSV or you receive a Parquet file or something like that. You may run DuckDB on it, the new kids on the block, which is, by the way, is fantastic. But that really doesn't represent like what a real, let's say, a company, what a real team will actually do, right? If your entire data value is in random Parquet file, dispersed all across your S3 buckets, it's going to be very, very hard to get value out of them, let alone a good feedback loop, just because it's very, very hard for humans to wrap around their head when the only thing you can see is files. So the first thing that we will need to do is moving from files to something that humans understand at a level of abstraction that allows them to make good mental models of what the system will do and to reason about what a pipeline would do in a way that is somehow predictable. So how do we go from a list of Parquet files that you can query, like one by one or manually aggregate to something that resembles a table and the semantics of a table? It has a columns, it has a schema. The schema itself can evolve over time. When you add things or remove things, you can go back to how things were, okay? And this is the typical advantages that people that have a data warehouse somehow boast about, right? It's like, hey, it was so cool about data warehouse that, that I can use my data in my cloud and I can still have table semantics over it. Well, thanks to the nice people at Iceberg, you can do that too in your data lake, right? So you can take, Parquet file, you don't have to move them to a cloud vendor or another SaaS product, and you can actually start thinking in tables over the files that you have in your S3, right? There are different ways to do this. Iceberg is one of them. Other choices that we consider were Delta Lake and Hoodie, of course, which are the three main options for you to achieve this type of table semantics of your data lake right now. And we end up choosing Iceberg when building and iterating on the first version of our platform, mostly because of like three points. Iceberg seems to be the more adopted, more popular, kind of like faster growing of these three framework. So it's a very large user base, which makes us comfortable that if Bauplan can read and write Iceberg, then remember the data lake vision of like different engine working from different use cases? Well, that will work because as long as we as a company can speak Iceberg, we can interoperate with, with all the other engines and all the other companies for other use cases, for example, Dremio. We also noticed that Iceberg is a very, very large contribution base, meaning that while there's one company, which is Tabular, that is kind of like taking upon himself to lead this new development, actually the number of companies, the number of institutions that are vested in making Iceberg better, including ourselves, is growing every day. And then when adopting an open source framework, that kind of puts your mind a bit at ease. It's not like one single point of failure. What happens if this company X cease to support this or now stop being open source? We think that the Apache Iceberg community is so large and so widespread that we somehow minimize the risk of this project becoming not well supported. And finally, there's a good, it's not perfect, but there's a good Python compatibility with Iceberg that may or may not be found in other solutions, especially when we started building a company like approximately 9 months ago. Python is important for us because our platform is built in mostly in Golang and Python. And a lot of our final user, as we discussed, will want to use Python on top of SQL to manipulate things. So Python is a first-class citizen for us. And the fact that we can interact with Iceberg-shaped tables using Python was very important. So when you put all this together, it was kind of no-brainer. And so we became like somewhat an Iceberg shop when starting building Bauplan. And we're being very happy so far with the results of this format. Of course, remember what we said in the very beginning about our specific use case, or like our target, right? Tables are nice. And, when we move from 5,000 files to a table that I can just query for, hey, can you tell me which schema this table have, is fantastic. But this is just one thing for us. Way more important than just single table taking point-wise, taken in isolation, is DAGs. Is the idea that when you run when a data practitioner works on this pipeline, is actually going to generate every run more than one table. In this case, remember this very simple pipeline that I show as a motivating example for today. There's a SQL query on your lake. There's a normalization step. There's another SQL to prepare a training set, and there's some like prediction that you want to make. All of these steps generate a table. It means that every time you run this, you're gonna get 4 new tables out of this. So we will need to go to a solution that is not just, hey, I have a bunch of files, I want to have a bunch of tables, but hey, when I create tables through my pipelines, I want these tables to be all created in some sort of atomic way. And we're gonna see how that looks like. So how did we solve this problem? And the way in which we solve it is turning again to the fantastic open source community. In particular, our choice for this is Nessie, which is an open source, I mean, as you guys, of course, know better than I do, is an open source project put forward by Dremio. Why Nessie is so important for us, and again, why Nessie and not other solutions? Because Nessie gives you this kind of like multi-table Git semantics, which is exactly what we need when we consider the type of workloads and the type of data practitioner that we're targeting. So we care about versioning table inserts, for example, but not that much. This is not really what data practitioners do. They're not focusing too much on ingestion. The problem that we have instead is, hey, there's a table where somebody else is ingesting data, and I need to work from that table to produce other intermediate artifacts to get my job done. So the cool thing about Nessie is that we can basically branch off production data, run, for example, the pipeline that I saw before. So creating 4 tables, one after the other, and all of those tables will not bother people working in production. There's a complete isolation data-wise between production and development, but this isolation doesn't prevent me as a practitioner to have the same result and the same data quality and the same data distribution that I would have by working with production data. So I get the best of both worlds. Remember the problem we started from, right? How do I work with production data fast, like without much overhead, without continuously copying stuff, or without breaking things, but without causing problem to me or other teams working with the same system? And Nessie provides you a solution. Nessie provides you a solution that in our Bauplan platform has been abstracted away even further from the user. But the general guess is the fundamental intuition of the Nessie multi-table versioning. So when you need to do some experiments, you need to run your pipeline because you believe it's slightly different than what it should be. You just basically branch off your data from the sources that you need in prod. You run your pipeline against that. And then when you're happy, you can merge it back. So this data catalog solution, plus the fact that all the tables, when generated, are in Iceberg format. So again, maximizing compatibility with all the fantastic engine that actually reads and writes Iceberg, makes the combination of Iceberg and Nessie our choice for this type of problem. What's a cool bonus feature that you get out of it? And without going into much to the details, because I don't think it's the focus of today's presentation, but I want to invite you to think about this fact. When you think about a pipeline, a DAG is basically a functional, paradigm, meaning that the parent of your DAG, for example, the query in your data lake, as a result, is going to be fed as an input to the child of this node, in this case, normalization. And the output of normalization is going to be fed as an input to training set or whatever that is. What does it mean? It means that the result of children is basically going to be always the same as long as the input doesn't change, right? And of course, we're used to this concept with code, right? If you don't change code, your pipeline, your script is always going to get, given some input, is going to get you the output. But the tricky thing with data system is that data keeps on changing, right? The data of today It's not the data of tomorrow. It's not going to be the data of 2 days from now. So the typical thing that happens in a data system is that something breaks on Friday, and then you need to debug it on Monday. But then when you run the same code on Monday, the underlying data source has been changed in such a way that it's impossible to reproduce the same result. Now, by using things like Nessie and Iceberg, so by having deterministic commits of your data structure, and by having a copy of your code thanks to Bauplan own proprietary platform, when you mix these two together, what you get is the possibility of debugging any pipelines anywhere all the time and be absolutely guaranteed that what happened Friday is going to be reproducible on Monday. This is an example from our syntax to show you how easy it is to actually accomplish this, right? So Bauplan run is our, let's say, standard CLI command running in pipeline. But if you supply like an additional argument, which is the ID of a previous run, the system has a metadata store such that it remembers exactly which code was used at that time, and it knows exactly where the data was branching off when that pipeline was actually run. So he's able to actually go back in time and time travel not just the specific query or a specific table, but is able to basically time travel your entire pipeline. It doesn't matter how long it is. It doesn't matter if it's like 3 nodes, 5 nodes, or 100 nodes. It doesn't matter if it's SQL or Python. As long as you can get the same code and the same data to start with, you're going to get the same result. So I hope this was a good overview of the type of choices that we're making while building Bauplan. Of course, I could touch only on very few aspects of building what we call a data lakehouse from spare parts. But we are very happy with the choice that we made so far as far as data formats and data catalog are concerned. There's way more to know and way more to do to build a compelling serverless data lakehouse experience. So if you are curious to know a bit more, heads up to our website or read our VLDB paper, which kind of gives you like a broader overview of the vision and a further discussion on tools that we couldn't discuss today. And of course, thanks so much again for coming today. And I'm happy to take any question you may have on what we discussed.
Hello, everybody. Okay, now we'll be doing some Q&A with Jacopo. There you are. Okay, cool. But yeah, if you have any questions, put them in the Q&A box or in the chat. But I do have a couple questions myself. First question is just kind of like about the implementation of like the Nessie catalog in Bauplan. Is that primarily for the execution of the pipelines, or is that something that's going to be exposed, and so that way other engines can then connect to that catalog to see all those the tables?
I mean, ideally, absolutely the second. Like, we believe data catalog and open format, both in the catalog and in the tables, are central for the composable lakehouse vision that we think is going to be the future. And so ideally, the same catalog would be available for somebody else in the company to be queried with a query engine such as Dremio, or to run like a machine learning model, because maybe they want to run like some Spark ML libraries on top of it. And we believe that there's no real opposition between running a pipeline and sharing the results. And the reason why we're adopting open formats is because we want everybody to work somehow on the same data without moving them.
Got it. And kind of like the inverse of that question is like, is generally the Nessie catalog, is that generally going to be provisioned by the Bauplan platform, or someone can bring their own Nessie catalog and plug it in, and then Bauplan will still be able to do everything? That's fine. That's
another fantastic question. So the second one for sure, as in if you already have a data catalog, as long as we can, work together with, integrating the API and blah, 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 all of that is fine for us. There's a bigger question, I think, for what if people have a data catalog that is not necessarily, any version of this. And then I think it's an open question at this point of the company of like, what is the best trade-off that we can make? One of that can be, we integrate with any data catalog for basic stuff, but you're not guaranteed all the nice thing that we can do for branching multi-tables, because some data catalog don't support it. Option 2, you have your own data catalog. We bring a Nessie with us, and we find a way to sync the Iceberg table between them, because Iceberg is way more like let's say, most popular data catalogs support Iceberg as single table artifacts. So there may be a way to go around this. But I also hope that other data catalogs follow, at least philosophically, in the footstep of Nessie pioneered in terms of like multi-table version.
Nope, 100%, 100% agreed. But okay, cool. Let's take a look, see if there's anything in the chat. Chat, that's the thing there. Oh, I see, there it is. Okay, and then other question, generally, like, what will be sort of like the, or actually, when is there a version of this that's sort of publicly available in beta or whatnot, or what's the sort of like timeline where people can kind of start getting hands-on with Bauplan?
So we are very early, so we're targeting for an alpha, which is going to be a closed alpha release. But if you're interested in actually check it out, just reach out to me. We'll be surely to put you in the wait list in the next couple of months. So by the end of the year, there will be actual Bauplan code that you can run and try out this serverless lakehouse for yourself. And then the, let's say, beta or more open release will be between Q1 and Q2 next year, so to speak.
Cool. And then we have one question. Any other query engine has adopted Nessie? Which there's a few, but
I mean, the one that I know of course, is Dremio. But like, if you have more, I'd actually be interested in knowing.
Oh yeah. There's a Flink supports Nessie, Spark supports Nessie, Trino supports Nessie, Presto supports Nessie, and I think there's other integrations being built as we speak. Yeah. And then I mean, yeah. I mean, that's sort of like the current state of things, but that's expanding. That's constantly expanding, and then in the future there might be some things that open it up even further.
Yeah, that would be like one complaint that I can make, if I can make complaints about open source, which I think is a terrible thing to do, as I've done open source myself. But like, I think Python, so like, I think a lot of these tools, and talking about Iceberg as well, they come from, of course, a JVM world, like broadly speaking, because of historical reasons we all know about. We don't have to go into this. But that's not the world that we inhabit anymore. And data practitioners just don't want to deal with all of that. So I think Python support as a first-class citizen of Iceberg. PyIceberg is a good example. And also Nessie, PyNessie is a good example. But I think investing heavily in those to be somehow feature parity with their jar counterparts will actually like significantly improve adoptions in the data world.
I 100% agree with that. One question right here: is Nessie tested on Iceberg interface to Delta tables? Far as I'm aware, like basically the way so this is referring to Databricks' Unity catalog. So I have been reading up a little bit on this recently, so I'll just say a few quick things. But bottom line is, like, if you're using Unity catalog, it's a different catalog. So it's like when you have your Iceberg tables, they're generally cataloged or tracked in a single catalog. So if you're using Unity catalog, that is in lieu of Nessie. But the way, so Unity catalog is Databricks' own implementation, and they're taking advantage of, in the Iceberg project, there's this REST spec, which provides sort of like a universal access layer. So anyone can create their own catalog implementation, and they can automatically use anything that has the REST catalog connector if they follow that spec. And that just kind of gives them immediate sort of engine support across the round. So that's what Databricks is doing. They're using that. So basically, when you create your Delta tables with the uniformat thing, which there's pros and cons to, but I won't get into that quite now. I did a couple episodes back. I talked about, I think in one of the Apache Iceberg office hours, we talked about that. But basically, you create your Delta tables. It generates Iceberg metadata, and the Iceberg metadata is exposed to that REST spec catalog. That's essentially what's going on. So Nessie wouldn't necessarily play a role in that picture. I mean, you could use the migration tool. There's a CLI migration tool that you could use to migrate from any catalog to any catalog, but that's different than keeping them in sync. And that's sort of a big question in the Iceberg stake right now. Like, what happens if you do have uses for multiple catalogs for different purposes? Because there are different bonuses you get for different catalogs. So how that evolves, I don't know. Do you have any thoughts on that? Like like, because you mentioned it earlier, like syncing catalogs. Like, what do you think sort of be like, if you were the guest, sort of like how that's going to evolve in the Iceberg space? What would be sort of your thoughts on that space?
I mean, like, once we have open source formats and interoperability, I think there will be I mean, I hope there would be a pressure on, let's say, lagging catalog to adopt some of the feature that more pioneering catalog like Nessie have. And hopefully we can all find common ground in the open format that we share. And then, like, my argument is, if data catalog by itself, I don't think is a choice, like, I don't think is a company in itself, meaning that if all data catalog will tend to resemble one another because they will have mostly the same functionality, I think the argument is, which is the best overall lakehouse thing that I can build? And then data catalog is a piece of that. I don't think it necessarily makes sense to have 4 data catalogs because they're slightly different in this hopeful future when everybody sort of agrees of like 3 things that all data catalogs needs to do. And so that would be my best. So maybe somebody's already vested in the Databricks ecosystem will use, Unity as a data catalog, but it doesn't mean that you cannot query Unity as an Iceberg format from other engine like Bauplan itself. So if somebody else is vested in something else, maybe they will do the opposite. Maybe the data catalog is in Nessie, but then Spark can read from Nessie. I mean, I read with Spark from Nessie all the time, so you can totally do that as well with Databricks. So that would be my guess.
Yep, nope, 100%. Okay. Cool. I think those are all the questions we have at the moment. Again, make sure to go check out Bauplan and keep up to date with the evolution at bauplanlabs.com. And also make sure to follow Jacopo on LinkedIn and on Twitter, so that way you can continue getting updates. And we will definitely, be following this and probably having Jacopo back on again in the future as the project evolves. But always great to see, applications of amazing technologies like Apache Iceberg and Project Nessie. And again, join us again next week. Next week we'll be talking. We'll actually have someone from 510 over to talk about ingesting data into Iceberg using some of I think some new features in 510. So that'll be next week. And then the week after, I think I'll be doing that one. And then I think that's going to be one about just sort of like basically how to reduce sort of like the cost of your overall data infrastructure, whether it's we're talking about network costs, compute costs, storage costs, etc. So that'll be a good one, especially if you've been staring at some fun cloud bills lately. But otherwise, Jacopo, thank you so much for coming to Gnarly Dataways. It's been a pleasure, and we look forward to having you on again in the future. And we really look forward to seeing the evolution of Bauplan Labs.
Thanks, Alex, for having me, and thanks everybody.